Okay, this video is what acidifies the tumor milieu. Tumor milieu is the tumor microenvironment. It's thought that things that acidify the tumor microenvironment favor the cancer to continue growing, because when you acidify the microenvironment around the tumor, that suppresses the immune system, and this pattern is thought to increase cancer growth. So sodium chloride, table salt, displaces bicarbonate in the blood. The chloride displaces the bicarbonate because you have a fixed number of anions, negatively charged anions. Like, chloride is a negatively charged ion, so is bicarb. So that causes a low-grade metabolic acidosis, leading to a low-grade acidification of the tumor microenvironment, the extracellular space around the tumor. Methionine is more common in animal proteins, amino acid, an essential amino acid. And so that's one of the big reasons why you want to avoid all animal protein to reduce risk of getting cancer, and it's thought to hopefully slow down cancer growth. So what you want to do is only eat animal foods, and I would also avoid beans if I had known cancer clinically, just because it's higher in protein overall. All plants will have all the amino acids, they just have relatively lesser amounts of methionine and certain other amino acids. Okay, the next thing is high sodium and low potassium diet, because what you want is to have a higher K factor. K factor is the ratio of potassium to sodium. So when you eat processed food, you get a lot of sodium and hardly any potassium. The opposite is the case when you eat plant foods. As a matter of fact, the most acidic foods tend to be the animal foods that got a lot of protein in them, the meats, versus the most alkaline foods, the most basic foods, tend to be fruits and vegetables. So you want a high K factor, high potassium relative to sodium, because when you've got the low K factor, that's associated with causing increased insulin resistance. It's thought the mechanism is that the relatively high sodium intake dissipates the plasma membrane sodium electrochemical gradient, and that weakens the sodium battery for pumping things like pumping calcium out of the cytoplasm. High cytoplasm concentrations of calcium leads to increased secretion of insulin, and the body becomes resistant to it. It's thought to be the mechanism from the Richard Moore book. Okay, and so that insulin resistance then is associated with, high levels of insulin are associated with causing the plasma membrane pumps to pump out more protons into the extracellular space, to acidify the extracellular space. I'm not sure why it does that, but that's what it does. Richard Moore went over that extensively in his book. You can also get high insulin levels from eating a high-fat diet. Okay, that's the most common cause of insulin resistance, and that leads in type 2 diabetes to the pancreas making more insulin, so you get high insulin levels. Okay, high-fat diets in general also cause tissue hypoxia, and that can lead to some acidification of the extracellular space. And it's thought that you're less likely to get cancer, and cancer is less likely to proliferate, it's thought, if there's less acidification of the tumor microenvironment, tumor milieu. So it seems to me I would do these things if I had cancer.